Now we're going to talk about probability, and it has a couple different examples that will go with it. We'll look at some basic probability situations that we'll come across in this class. If you take stats, you go into probability more in depth, and you can actually take a class in college that is all focused on probability and stats, and you would go much more in depth. But today we'll talk about coins, we'll talk about dice, numbers, etc. So 2 coins are tossed. What's the probability they both land heads up? So we've got 2 different things happening. We toss a coin and we toss a coin again. What's the probability the first one is a heads? 1/2. What's the probability that the second one is heads? 1/2. So the probability of 2 events, this we'll get to when we talk about it down here. 2 events, you can multiply their probabilities and you get 1/4. Now this does only work when you have independent events, which means the first coin toss does not affect the second coin toss. They are independent of each other. But if you have multiple things happening, you can just multiply their probabilities if they're independent. Now we're going to talk about dice. You have 2 6-sided dice that are tossed. Now what I did is I grabbed a picture of all the possibilities. You could have a 1 and a 1. You could have a 1 and a 2. You could have a 2 and a 1. Any of these could happen. So with 2 dice that have 6 numbers, 1 on each side, you could get a 1, 2, 3, 4, 5, or 6 on the first die. You could get a 1, 2, 3, 4, 5, or 6 on the second die. So there's actually 36 total things that could happen. What's the probability that the sum on the dice shown is 7? Well, there's 36 total possibilities, and if I go and look, 1 plus 6 is 7. So that would be a success, getting a 7. That would be a success. Here, 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 and here. So there are 6 different ways to get a sum of 7 out of the 36 total. That can be reduced to 1/6. I'll do the same thing with 11. I could have 5 and 6 or 6 and 5. So there are 2 ways to get 11. So I would say for part B, 2 out of 36, or 1/18. 4, that would be more up in this corner. 3 and 1, 2 and 2, 1 and 3. There's 3 different ways to get a 4. So I would call that 3 out of 36, which would reduce to 1/12. C, B, A. For my next example, it says a random number generator on a computer selects 3 integers 1 to 20. What is the probability that all 3 numbers are less than or equal to 5? So we're going to assume that a random number generator does not remember what it chose on the previous integers, so they are independent. So I have 3 different things happening. I pick an integer, I pick an integer, I pick an integer. What's the probability my first one is less than or equal to 5? Well, it'd be 5 out of 20. Now I pick another one, 5 out of 20 again, and 5 out of 20 on my last one. So I'll do 5 divided by 20 cubed, and the fraction of that is 1/64. So I get to use that independent probability, multiply the probabilities idea again. My last example, example 4, says a manufacturer has determined that a machine averages 1 faulty unit for every 1,000 that it produces. So the probability of faulty is 1 out of 1,000. The probability, I'm going to call it of not faulty, would be 999 over 1,000. And that idea is the idea of a complement. If you have one probability of like faulty, the complement is the opposite of that. So if faulty is 1 over 1,000, not faulty is the complement. And it would be 999 over 1,000. So the probability that you get something that works is this. Doesn't work this. So what is the probability that an order of 200 units will have one or more faulty units? This is a hard question because one or more faulty units mean you could have one faulty unit, two faulty units, three faulty units, four, all the way up to 200 faulty units. So it's actually a 200-part question. You'd have to find all of them and add them up. We are going to do the opposite of that, or the complement. The complement of one or more faulty units, complement, is no faulty units. And complement would be 1 minus the probability of that happening. So we are going to do 1 minus this. 1 minus the probability of no faulty units. All right, so how do we get that? I'm running out of space, so I got to move up here. What's the probability of no faulty units? Well, no faulty units, we have not faulty here, would be 999 over 1,000. And it has to happen 200 times in a row. So we have to raise it to the 200th power. So the answer to this question would be 1 minus 999 over 1,000 to the 200th power. So it'd be about 18% that you would have a faulty unit. So about 18% of the time, if somebody orders like 200 units, they would have a faulty unit at least once. The other, 82% of the time, they would not have a faulty unit.